Great. So sorry for that. I went back for something. So we want to go to a directory where we have so that is the directory where we will be running our NID, and then I want to activate a Conda environment. Conda, we activate, I have a Conda environment by that name, by GIS. So when that activates, select some minutes before it activates. So when activate, we need to open a Jupyter notebook. Yes, we open a Jupyter notebook. So that Jupyter notebook will open on the, should open on the, I will post the video for a moment, and then when it's finished, and then I'll share. So I've posted just a moment. Not sharing my screen now. So just a moment. I'm waiting it for it to start. So don't worry when you don't see my screen, because I want to achieve some things around here. I'll share the screen when it is back, when we're already running the code. So it will be very easy. So just a minute. Also understand also these things require network. So this things require network also needs some. So I also did a code in. I also did a code in Python. The code in Python is, as you can see, it is still yeah, it was supposed to be Nairobi. Now, I'm sorry for also taking another time of you. Now, this is in Python. The other one was in JavaScript. But Python in this case has got very unlimited capabilities. But in this moment, I have limited capabilities on my end when it's come to implementing the same architect here. Not like limited as such, but I can say it is more of a time frame that I have. I can implement the same procedure even in Python, but this is the time. So this is our challenge, and the challenge is a fun green space and tree cover. We are using a satellite image. This is the challenge, and that is me. You can look into those links. Some useful links for people who are new to Google Earth Engine. You can go and read documentation, go to Keymap for Python package. There are more than 55 videos now. It's not just 55. Right now, it is more. You need to have a Google account. You can sign up. You also need to have an Anaconda. This one. See, now I'm running an Anaconda here. So see this breaking some section, doing 1, 2, 3. So, and you can do this when you have an Anaconda. You run this environment. So our problem understanding is that we need to develop AI solution that will extract data from satellite imagery hosted on cloud, like Google Earth Engine. We also need to generate statistics of urban indicators. And those indicators are change in green areas per capita. As you know, this was in 2020. So this is the green areas in 2020. Vegetation in 2020. So we can also do vegetation in 2010. We do it in 2000. Then we can come back to our code. We understand that we can do the per capita. Then we also need to do the tree cover change, which is defined by our indicators as that one. So we will need, as I said that you will do the 2000 sync snap. That will be great. We also wait and see. And I'm really also, okay, although I have used Snap several times, I've also used QGIS. I'll prefer cooler engine for remote sensing data because they are very heavy. So our analytic approach is that we are going to use a supervised classification machine learning, where we are using a classifier, instantiating a classifier as I had shown earlier. Then we are going to run this algorithm through random forest. You can run through all these others and then check their accuracy. The general workflow is the same. You can also estimate classification errors. The same explanation about feature collection that needs to carry data from zero, and then we can remap. Now, our data requirement is this. You need to collect the training data for Nairobi County sharefiles. So we already have a shapefile. We already have satellite images. Then we know our period of study. So we need 4 classes. We can add all these 4 classes beyond 4. This just for this case. We generate statistics and time series. Then we estimate. We need to collect data, as I've shown here. This is which I've extracted from this place. You can also do it yourself. Training data also, I've drawn simply through there, and then you can use any other Sentinel or Landsat. Now, our understanding of data is that at least of Kenya geospatial data has got all the 47 counties, but using QGIS, I can select attribute and then click so that we get Nairobi. For the training data, we manually collect study area by drawing tools, Art Engine. Satellite image consists of image collection, so we will be able to know and we can filter regional from all those years. I wanted to build a Landsat 7 Narera has a lot of clouds, so it requires a lot of cleaning. I will wish to know if there are people who understand how to clean satellite images. We can download and so we can clean. Then once we are done, we can extract our data and we visualize. But in this case, I don't think we will be able to implement this at this moment because of time. Now, we also need to do feature engineering, where we need to merge features together. We need to display Nairobi shapefile and use to get some statistics we can calculate. You see, I wanted to do all this. We need to do NDPI, normalized different build-up index, normalized different worth index, normalized different precipitation index. Then we use to run. Then we need to have our training points and run the classifier. We are modeling criteria. We'll use random forest classifier. I'll still expound on that. And our final results will have 4 categories. We will have water, vegetation, build-up, and PLR. We also have a time series of images and zonal statistics vegetation for each year, plot time series. We also develop an app where once our analysis is done, we can be able to develop an app as I showed you, Google Earth Engine. Then we can also use keymap and then do there's another way we can use Python and then so let's dive into the demo. Then we see what we import the libraries. Then we run that. So if it will take time, it will help you understand because of the whole network. So I might pause and come back, but I don't think I'll really pause in this one. Yeah, so as you can see, so you see, this is already a classified image, so we can work with this at the moment. But this is a 30-meter resolution. We need to have something more than 30. Let me run all this so that it will be a bit faster. Then I'll explain. As the scaling factor. So there's a list for 2000. Then we'll see if they are giving us. So already this working. So it is already, this one is importing libraries. Now we will come here and create an interactive map. So the libraries that I have imported OS, Art Engine API, keymap, then volume. This I'll use later for mapping, although I'm not using now. I can create an interactive map, which is this one. So you see, it's just an interactive map. It's not a specific place, but I can customize that map to my area. See, I've customized my area. Yes, Nairobi. Now Nairobi, I can load the Nairobi shapefile. This is already loaded, preloaded, because I ran everything. But you see, I prepared Nairobi here, as I said, in QGIS, and then export it to data, my folder here. We have a folder here called data. And then I can add it here, and then use it and add it to map like this one. We need to apply some data set, right? So we haven't imported the data set, so we need to import some data set. Now, we really don't have to apply all this. I think I just run this code for should have been here. So I can't remove that now. So we can load an image. We can load an image for Landsat 7 that we feel that tonight, the same ways we were doing. Let me run this and see if it's giving errors. I hope it doesn't. And it adds an image. That is another thing that we need. We really don't just need see, so we are not getting any image at all. See that? But we can, I think we can use the one that we were using before. So that is still the code on progress, you see? So we're still not getting an image because one, these scaling factors, when if I use things and we go and see what we mean by this one, this Landsat 5, yes. So this is from 1984 to 2012. So it was decommissioned in 2012. Now its spans are this one, as you can see, and you see it has got a scale factor that you need to apply. Every other time you are running it, you need to apply from blue, green, red, near infrared, shortwave, infrared, too. And then the other bands within, see? But we're interested with these two bands. So I will finish on the Python, the Python side. When I finish on that, I will share maybe, yeah. When I finish on the Python side, I'll share the final. As you can see from here, there's very little that it has happened. We are already here. We are still like understanding the problem on the Python side. It's not much that even like understanding the problem, but when it's come to coding, we are still at chapter 2. So we'll still need to go down here, calculate all these analytics, do all this data requirement, understanding, and feature engineering and modeling. This is something that I'll push later or tomorrow to GitHub. So at least when I finish doing the site. Otherwise, I think that that is okay for now. And I'm very grateful for your time. We'll still discuss. We'll still share. But it's just a sample. I wanted to show a sample of what we can be able to do with Python, Keymap, and Kulat Engineer. Thank you very much, and have a great week.